Finally, in terms of complex numbers, we're going to finish off with these problems here. Cos theta plus I sine theta to the power 5, all of it. Cos theta plus I sine theta, all of it to the power minus 15 to the power 7/2. And then we have a scenario where we have cos 3 theta plus I sine 3 theta over cos 6 theta minus I sine 6 theta. Simplify. So here we know that our vision is to expand these out, but our vision here must be to simplify this. Hopefully we have been watching this series to the degree, or from other practice, of course, we can see that the tool we shall have to use for this is probably, of course, going to be multiplied by this complex conjugate of the denominator. And for these, let us take you through the structure. So first of all, the first one, de Moivre's theorem. If you haven't seen the series or on de Moivre's theorem or had it taught to you in class, etc., please do so. Generally, it is quite fundamental to know the theory. That does not mean to say that you cannot do these problems without the theory, but it does mean that there'll be less anxiety in an exam, and the more complex the problem gets, the better you shall be at dealing with it. Now, generally speaking, the rule is quite nice, though. The rule is simply to just bring the 5 down in front of the theta, and the same, therefore, for this one. And hence you can see that cos theta plus I sine theta is exactly the same as cos 5 theta plus I sine 5 theta. That is to say, all that we had to do to expand it, and therefore this is the answer, is to put the 5 in front of the theta. The same goes for the minus 15, but this would lose marks, for example, if it were an exam question. Say there were 2 marks for this question. The reason that you might lose marks here is to do with the fact that this can be said to be not simplified. We have a minus 15 theta in front in terms of the cos, and the angle for this sine is minus 15 as well. A couple of things to just be aware of. Cos, I believe, we can see cos quite comfortably. If we just take a look at here, you can see that the right-hand side for cos, that being the positive, the first quadrant and fourth quadrant here, this right side of this graph, is exactly the same as the second and third quadrant of this graph. And we say, of course, that means it's an even function, but another way of viewing it is to simply consider that no matter what value you choose for x on this side, the output value will be y. The same negative value for x will produce the same output value. So, for example, we'll do 3 here. 3. So this would be a minus 1, of course. And you can see that on this diagram here, the same thing manifests. It was still producing a minus 1 for the minus 3. So the opposite number produces the same output. So this manifests itself in the algebra in that minus 15 theta will be the same as 15 theta. So therefore there's no need for this minus sign. For sine, it can be seen as perhaps a little bit more complicated in terms of understanding the negative, but not too much. That is to say, this is your sine theta graph. This is your basic sine. Here, let's write this in, or you'll often use the phrase sine x. I'm going to remind us here that sine x, hopefully you can see the sine x is exactly the same there. So that's our sine x, this one here, the green one, for those that can see the color. That's sine x. Now, if I were to say that this one here can be described as sine minus x, like so, and the reason for this, let's see if we can use some diagrams. Let's say, for example, this point here is 90 degrees. At 90 degrees, sine theta, opposite divided by hypotenuse, will produce a output value of a 1. That's what happens at 90 degrees. Now, if I were sine minus x, if I was to try and plug 90 degrees in here, it would read minus 90 degrees. So it would read this value, minus 90 degrees, which gives us minus 1. So instead of giving us plus 1 for sine x, sine minus x, for the same 90 degrees, 90 will convert into minus 90, which will give us an output value of minus 1, and hence, therefore, in the graph of sine minus x, the output value for 90 is minus 1, because it is as if it is reading minus 90, which is minus 1. And this continues with every angle that is placed in it, giving you this flipped looking graph here, which of course is the base rule if you our practice with translations in terms of graphs. Now, this therefore means that we can argue that this one here is sine x and sine minus x is here. Okay, brilliant. But let's also just take a look at minus sine x. So minus sine x. So this one here is our original sine x. And this one that I'm going to draw on top of this hump is minus sine x. I'll even put the brackets in just to look a little bit more, I'm not sure, proper. Now, in this circumstance, you can see why that might be the case. If I were to choose 90 degrees as before, 90 degrees would lead to a value of 1. However, that's the output value. If I type in 90 into here, it would produce 1, and then it would be multiplied by this minus sign, making it a minus 1. So sine minus sine x would produce a minus 1. And this is the same for all values. The equivalent output value that is positive produces a negative output value. So it literally is the equivalent of, again, flipping it. Notice how minus sine x is the same as sine minus x. So how can we put all of this into some sort of applied situation? This I sine minus 15 theta is the same as sine 15 theta, but with a minus sign in front of it. Why? Let's just make sure that is the case, to make sure it's possible to describe this clearly. Perhaps that is sine minus x is exactly the same graph as minus sine x. You can see there, that is your minus sine x. This is your sine minus x. They're exactly the same graphs. Hopefully, there will be some understanding as to the reason why. If not, either play back or specifically see tutorials or descriptions as to why this is the case. Perhaps graph them yourself. But overall, for this video here, for this problem, generally you can see that those two are the same things. However, sine minus x is a little bit nastier to look at, for want of a better phrase, than minus sine x. So therefore, when you see a minus, I don't know why I had to do two arrows there. When you see a minus theta, we'd rather write it so as with the minus sign in front of it. So anyway, we got cos 15 theta minus I sine 15 theta, and that is the best way, the best solution for that one. So generally, just be careful in terms of remembering your trigonometry. This is an even function, so there's no need for the minus sign, and this is an odd function, or that's another way of viewing it, but generally the minus sign in terms of the theta can be placed outside for sine, and that gives us that solution. For 7/2, there's nothing more than you can do 7/2, use de Moivre's theorem, and you get 7/2 theta plus I sine 7/2 theta. And again, please see de Moivre's theorem for the theory behind that in addition. Okay, so finally, this last lovely one here, cos 3 theta plus I sine 3 theta, cos 6 theta plus minus I sine 6 theta. Well, as I've taken another route for this one, just because the repetition of doing the complex conjugate of the denominator perhaps might start to get on people's nerves. Generally speaking, what I've done is I've decided to multiply it by minus 1 in terms of the power. And the reason for this is, of course, hopefully y'all can remember that the denominator is the same as to the power minus 1. Given that this is the case, I can then use de Moivre's theorem as we've been doing, so this shouldn't be too much of a jump in steps of logic. Bring that power in front of the 6 to produce cos minus 6 theta minus I sine minus 6 theta. Using exactly the same rules, even cos here just turns into cos 6 theta, and the minus will be brought to the front, making minus times minus, which makes this plus. Henceforth, then we can use the rules used in the last video, which is the double angle formula, which I thought would be a good way to tie up all of this situation, simply because you can see that this hopefully is, when you multiply this out, I'm not going to do it all in this video, but cos 3 theta would have to be times by cos 6 theta, then cos 3 theta would be times by I sine 6 theta, I sine 3 theta will be times by cos 6 theta, and I sine 3 theta will then be times again by I sine 6 theta. When you write that all out and look at it in terms of what identities it suits, and please see my last video for more detail into that, you will find that it fits very well cos 3 plus 6 theta this time, plus I sine 3 plus 6 theta this time, which produces cos 9 theta plus I sine 9 theta. Thank you for your time in regards to that.